Hello guys, in this video I would like to explain about selecting statistical test and hypothesis testing. This video is mainly concerned with hypothesis testing about one population mean and two population mean. And remember that we have some assumption about when we are testing about population mean that the population is normally distributed and the variance is known or unknown. That depend which statistic then we can use depend on the variance whether it is known or not known, and also it depend on the sample size. In case of sample size is large and the sample population variance is unknown, still we can use normal distribution. So this video is related to see in which situation we can use which statistical test, and you should remember that this is the most critical step in hypothesis testing, that which test statistic you can use looking at your data. And before this video, we have done some videos about hypothesis testing, which was the basic video was about what is hypothesis and example from the real life. And then there was other test video as well. One was how to construct the critical region in hypothesis testing. And then there is another video which is how to do hypothesis testing and SPSS. So if you want to know about those videos, the links are given in the description of this video. Just click on the link and you will see. You can watch the videos. And if you don't know about those, basic definition of hypothesis and the formulation of hypothesis, the general procedure of hypothesis, then that can be difficult for you to follow this video. So please watch those video, and then you can watch this video, and then this will conclude that which test as useful or you can use in which situation. That mostly depend on the assumption that the normality assumption is valid for all statistical tests, which we will discuss in this case. And then the other assumption is whether the population variance is known or unknown, and the third assumption is independent of the sample. That will be mostly we will talk about this in two population case. So let's move to the content and that how we can talk about this. Well, now the first case is about one population mean. You can see that the one population mean. So we are talking about testing of hypothesis about one population mean. So how we can select test statistic and which test statistic we can use. Usually when you are testing about the population mean of a normally distributed population and the population variance is known, then you can use z, that is equal to x bar minus mu and divided by sigma by n. We can use this as a test statistics, and this has a distribution, standardized normal distribution with zero mean and unit variance. So that's mean the population is normally distributed and the population variance is known. You can use standard normal distribution regardless of the sample size. The second case is population is normally distributed and population variance is unknown. Remember that the normal distribution is valid for all tests we will talk about in this video. But then the other assumption are changing, like population variance is known, unknown. In case of two population, whether the sample size are independently distributed or not. So you talk about that later. In this case, population is normally distributed, population variance is unknown, and small sample size. This is another thing which we can add. Sample size is less than 20, or you can say 30. Mainly that is 30, but in some box it is written 30. But I agree with that. If sample size should be less than 30. So, but it is mentioned because in one book I found this, but I agree with the less than 30. So in population, sample size is less than 30 and population variance is unknown, then you can use t distribution, that is x bar minus mu divided by s divided by n square root, which is distributed t, student t distributed with n minus 1 degree of freedom. That's important to know because then you need to check the values, the critical values, not the critical points. When you're calculating the critical region, you need to use t distribution with n minus 1 degree of freedom. That's mean when we have 10 sample size, the degree of freedom should be 9. Population is normally distributed, population variance is unknown, and large sample size. So large sample size mean when n is greater than 20 in some books, but again I will say n is greater than or equal to 30. That is according to CLT, central limit theorem. When the sample size is increasing, other distribution converging to normal distribution. So this means that when n is greater than or equal to 30, then you can use either z or t. And why we can use z or t? Because z is okay, because with the large sample size you can use z. But why t? Because according to central limit theorem, when the sample size is increasing, other distribution converts to z, to normal distribution. So that's why you can use a t distribution or z distribution. There can be very less difference in the construction of theoretical values. So this is all about one population mean. Now let's move to two population testing hypothesis about two population means. How we can select test statistics. So that the population is normally distributed and independently distributed. Remember, now there are two assumptions in case of two population, that population is normally and independently distributed and population variances are known. Remember three assumptions. So in this case, you can use z, that is x bar minus y bar minus mu x minus mu y, that is mu x is the population mean for first population and mu y is population mean for the second population, and this is the sample mean from the first population, and y bar is the sample mean from the second population. Sigma square x is the population variance of the first population and sigma square y is the population variance of the second population. N is the sample size from the first population and M is the sample size from the second population. That is distributed normally with zero mean and unit variance, because this is standardized form, by the way. And remember that in this case where N and M can be different, that's mean the sample size from population 1 can be 10 and from population 2 the sample size may be 15. That's mean it's not necessary that the sample size should be equal, not necessary. So look at these assumptions and then you can use this as a test statistic when you are testing about two population means. And now in this case, number E, population as normally and independently distributed. This is the same here, but population variances are unknown and small sample size. Yeah, I mentioned here too. No, it's okay. Yeah, of course, you need to mention both sample size should less than 30. It is mentioned 20. That's okay, because in one book it is mentioned 20. But I strongly agree with that. According to central limit theorem, we consider the sample size small when it is less than 30. So n should be less than 30 and m should be less than 30. Then you can use t distribution as we have used in single population, that is sample mean from the first population, sample mean from the second population, and then the same way means of the first population and second population. And then remember that variances are unknown, so you need to calculate sample variance from the first population, sample variance from the second population, and again n and m are the sample size for the first and second population respectively. And this has a distribution, t distribution with n plus m minus 2 degree of freedom. So you can use this n plus m minus 2 degree of freedom. Suppose n is equal to 10, m is equal to 12. So that's mean that is 22 minus 2. So you have t distribution with 20 degree of freedom. You can use this to construct theoretical region. So this is now for sample size less than 30. You can use t distribution when the population variances are unknown. But when the sample size is greater than what? I have not mentioned here, but this is just like the single population mean, like n is greater than 30. Similarly, we can say if n is greater than 30 and greater than equal to 30 and m is greater than equal to 30, then again you can use z distribution or t distribution. Z distribution, just you need to write z here, and because the sample size is large, and so you can use this as square x and square y instead of sigma square s sigma square y, because this again approaching to normality. And so that means you can use Z distribution or T distribution, because with this increasing sample size, T distribution approach to normal distribution, so does not make no significant difference. You can get approximate normality. So in that case, when is greater than equal to 30 and M is greater than equal to 30, you can use Z distribution or T distribution. Now this is a F case, population are normally and independently distributed. So okay, this is the same assumption, and population variances are equal and unknown population variances are equal, then use this as a test statistic. That's mean the population as normally and independently distributed, and the unknown variances, the population variances are unknown but they are equal. This is the assumption. Then in this case you can use this as a test statistic. Again the same in the numerator and denominator, you can say SP square fold variance n to 1 divided by n plus 1 divided by m. N is the sample size from first population and m is the sample size from second population, where SP square is equal to, you can say this is the weighted variance. We call this fold variance. So you can see n minus 1 into x square and m minus 1 into s square y divided by m plus n minus 2. So you can do in this way when these assumptions are meet, then population are normally and independently distributed and unknown population variances are equal, as can be mentioned in the problem. So that indicates you can use this test, which is again distributed as a T with n plus m minus 2 degree of freedom. Now the last case is G, and in this case the population is normally and not independently distributed and unknown population variances are equal. So what is the difference between these two? Only this assumption, independently distributed, that is not independently distributed, the remaining assumption are same. In this case you are using T is equal to D bar minus mu D divided by S square D by N, and that is distributed T with N minus 1 degree of freedom. Remember that D bar is equal to xi minus yi. That's mean first sample values minus second sample values. And remember that in this case, the values should be equal the sample size. That's why we mentioned that by n. D bar is equal to this one when you're calculating this D bar series by subtracting y from x. That is D bar when you're calculating the mean. Remember that you can calculate, then this is D. Remember, I'm sorry, this is D. This is not D bar. This is D is equal to, or you can say DI is equal to xi minus yi. So when you calculate D series, then you need to calculate mean of that D series. So that is equal to D bar. So remember, this is not, you can write a summation and then bracket nxi minus yi divided by n, that will be D bar. But this is DI, not D bar. So you calculating DI is equal to xi minus yi, then you can calculate the mean of that series, which is DI, so that is D bar, and then you can calculate, you can have the population, mu D, that can be mu x minus mu y, something like this, or maybe the differential directly mentioned. If not mentioned, then you can write mu D is equal to mu x minus mu y. And standard deviation of D, standard deviation D square, standard SD square, that is the standard deviation, or you can say here it is square, so it is the variance of the series DI. So D bar is the mean of the D series and S square D is the standard variance of the D series, and N is the number of sample point. So you can calculate this, and this is still distributed in minus 1 degree of freedom. Okay, so this is all about that how we can select a test statistic while testing the hypothesis about a single population mean and about two population mean. I hope this explained in detail, and still you have problem, you can write me in the comment box, the comment section, if something is not clear, or if you want something that I should explain. So thank you very much, and see you in the next video. Ciao.